Hello class. In the last session we discussed about the design aspects or the design issues at the transport layer. Now in this session I'll be sharing about the basically the some more details about the design aspects at the transport layer. You can recall that there are basically two types of the services, the communication services. One is called the connection oriented service and the other one is called the connectionless service. So for both of these kinds of the services to be facilitated at the transport layer, we have the corresponding mechanisms. First of all, we shall take up about the connection oriented service and then about the connectionless service. In most of the situations the connection oriented service is used, whereas in some others the connectionless service is used. When we talk about the connection oriented services, the transport layer has a specific kind of the protocol that is known as the transmission control protocol, or TCP in short. This is what we are talking with reference to the TCP/IP model. So according to the TCP protocol, there is a need of a proper connection management mechanism. So we can see there is an important issue of what we call connection management. In the connection management, the end-to-end delivery can be accomplished in either of the two modes, that is either the connection oriented or connectionless, as we have already discussed. Then the connection oriented mode is the more commonly used, as it has been shared. Now for the connection oriented transmission, it has three stages. जो आपका कनेक्शन ओरिएंटेड ट्रांसमिशन है, इट हैज़ गॉट थ्री स्टेजेस, तीन स्टेजेस हैं. वन इज द फर्स्ट वन इज कॉल्ड द कनेक्शन एस्टैब्लिशमेंट, सेकंड वन इज कॉल्ड डेटा ट्रांसफर एंड द थर्ड वन इज कनेक्शन टर्मिनेशन. यानी सबसे पहले आपका कनेक्शन एस्टैब्लिश किया जाता है, उसके बाद जो भी रिक्वायर्ड डेटा ट्रांसफर है वो परफॉर्म होता है, और एट द एंड ऑफ द डेटा ट्रांसफर, आफ्टर दैट द कनेक्शन इज टू बी terminated. So these are the three stages in the connection oriented transmission. So we see about the first stage, that is the connection establishment. The connection is established. For establishment of the connection, there is a protocol called three-way handshake protocol which is used. So we shall see how this three-way handshake is performed and the connection is established. This can be seen in the diagram. In this timing diagram, we have the requesting computer on this side and this is the responding computer. This is the timeline, right? So we can see that in this process of three-way handshake there are certain primitives, basically three primitives. There are three primitives which are used. The requesting computer sends this command or primitive called connection request to the responding computer. So this connection request primitive or the command, this is sent by the requesting computer to the responding computer. The responding computer, on getting this request, can sends the connection confirmation, this primitive connection confirmation, which is received by the requesting computer, and then the requesting computer sends the acknowledgement of this confirmation to the responding computer, so that when the responding computer receives this one, both the parties, that is the requesting side and the responding side, are sure about the establishment of the connection. Right, so this is how the connection is established by means of these three primitives, and that is why this protocol is called the three-way handshake protocol. The connection establishment requires three actions in what is called the three-way handshake protocol. So this is how a connection is established. After establishment of this connection, the required data communication or data transmission takes place, and then at the end of the data communication session, after the whole data transfer has taken place, the connection is to be terminated. So we can see that what happens in the connection termination. We can see once all of the data have been transferred, the connection must be terminated. The connection termination also requires a three-way handshake, same as what we have seen earlier, and this is also under the three-way handshake protocol. This is also under the three-way handshake protocol. So for disconnection or connection termination, we can understand this with the help of this diagram. We have in this timing diagram the requesting computer, the responding computer. In this also we have the similar kinds of the primitives. Only thing is that we have to replace connection by disconnection. You can see. Say requesting computer sends disconnection request to the responding side. The responding side sends the disconnection confirmation to the requesting side, and then the requesting computer sends the acknowledgement of this confirmation to the responding computer. After that, both the parties are sure that the connection has been terminated. Right, so I hope that this mechanism of three-way handshake protocol has been clear under the connection oriented service. So this is what we have in the connection oriented service. Then we can see there can be connectionless service also. We can see that the connectionless transmission mode or the transport services provides a single freestanding data unit for all transmissions. This is the difference, because in the connectionless transmission mode we do not have any dedicated connection as earlier, and rather there is a single freestanding data unit for all the transmissions. Fine. Now we shall see under both these protocols what is the kind of the data unit which is used, that is what is the format of the data unit. We can see that the under the connection oriented service, or we can say the TCP protocol, we have the data unit in the form of TCP segment, whereas under the connectionless service the kind of protocol is UDP protocol or user datagram protocol, and the data unit is named as the UDP datagram. Both of these we shall see in details. Let us see first of all the details of the TCP segment. The TCP segment has this kind of the format. We have two parts in this, the header part and the data part. The header part and the data part. The header part is minimum 20 bytes and maximum 60 bytes in size, and the data part is maximum 495 bytes. So we can now further explore the header part in this, how the header is formed, what is the format of the header. This can be seen. The header has got these fields. The source port address of 16 bits, this is the first field, followed by destination port address 16 bits. Then we have the sequence number 32 bits, acknowledgement number 32 bits. This is followed by HLN 4 bits, reserved 6 bits, URG of 1 bit, ACK 1 bit, PSH 1 bit, RST 1 bit, SYN 1 bit, FIN 1 bit. Then we have the window size of 16 bits, followed by checksum of 16 bits, urgent pointer 16 bits, and at the end we have the options and padding bytes. So this becomes the format of the header. We can see the header size is minimum 20 bytes, maximum 60 bytes, and reserved field is used for the future use. We can further explore these various fields in some details. We can see in the TCP segment description of fields. The first one is the source port address. What is the source port address? This is the address of the application program in the source computer, or we can say the basically the socket address of the source application, including the port number. This is basically the source port address, port number or port address of the source. Then we can see the next one, sequence number. Similarly, you will have the destination port address also, followed by the sequence number. Sequence number is the position of the data or the TCP segment in the original data stream. आपका जो पूरा ओरिजिनल डेटा स्ट्रीम है दैट इज डिवाइडेड इनटू नंबर ऑफ टीसीपी सेगमेंट्स, तो उसके अंदर उस टीसीपी सेगमेंट का क्या सीक्वेंस नंबर है दैट इज मेंशन्ड ओवर हियर. देन वी हैव द एक्नॉलेजमेंट नंबर, एसीके नंबर फॉर एक्नॉलेजमेंट नंबर, which means the byte sequence number that is next expected, next byte sequence number. Then we have the HLN for header length in bytes. It is again the multiples of 4, maximum 60 bytes, the same way as we have seen in the IP datagram. Then we have the reserved field, which is used for the future use, reserved for the future use. This is followed by, there are 6 1-bit fields each. That means it can be either 1 or 0. 6 bits. These can be set or reset. So the first one in this is URG for urgent. This indicates that the data and segment are urgent. Means if this bit is 1, means the data is urgent, otherwise normal. So as per the need, this can be set to 1 or 0. Then we have the ACK field, acknowledgement field. This validates the acknowledgement number field. It tells whether the current segment is an acknowledgement segment or not. If it is so, then it will be 1, else 0. Next field is PSH for the push through. That is, push the data through paths with higher throughput. If the higher throughput is required, then it will be set to 1, otherwise 0. Then we have the RST field. Reset the connection if there is confusion in sequence numbers. If there is any kind of the confusion, then the reset will be done and this field will be set to 1. SYN is for synchronization. SYN is for the synchronization field. This is used for the synchronization numbers, sequence number synchronization in 3 types of the segments. There is connection request or connection confirmation or confirmation acknowledgement. That is basically during the connection establishment. For the connection establishment, this will be set to 1. Then we have the FIN field. FIN field, it is used in the connection termination or connection finish. 3-way handshake. So in case the connection termination is taking place, FIN field will be set to 1. Right? So this is about these fields. Then we have the next field called the urgent pointer. This defines end of the urgent data and start of the normal data. In case there is there was urgent data. This defines the end of the urgent data and start of the normal data. The last field being the options and padding field. This is basically to convey this is optional field basically to convey the additional information to receiver or for the alignment purposes. So if required, this will be included. Right, so this has given us an idea about that what is the typical format of the TCP segment. Then further to this, we can see about the UDP. This was all part of the TCP. Now we can see few things about the UDP. About the UDP, we have seen the UDP stands for User Datagram Protocol, and this is meant for providing basically the connectionless services. For providing connectionless services, the kind of the data unit being used is known as the UDP datagram as per the TCP/IP protocol. So now we can see what is the format of the UDP datagram. The format of the UDP datagram can be seen that this is a freestanding data, and therefore it has the two parts in this. This datagram has two parts in this. First part is called the header part, and the second part is called the data part. The header is of the size 8 bytes, and the remaining is the data part. This can be variable. So in this we can explore the header field. The header part is explored, and we can see that there are basically 4 fields under the header. The first field called the source port address in 16 bits, followed by destination port address 16 bits. Then we have the total length of the datagram in 16 bits and the checksum in 16 bits. These are the 4 fields which are self-explanatory, whereas we can share briefly that the source port address is basically meant to hold the address of the port of the source. जो source application का port number या port address है, that will be part of this field, जहाँ से जो application invoke करेगा और send करेगा, so it is the address of that one. Then similarly in this field we have the address of the port of the destination application. Right. And then we have the field called total length of the datagram. पूरे datagram का जो total length है in bytes, it will be stored here in these 16 bits. Followed by the last one, that is the checksum field. The checksum field is basically to check the integrity of the header. It checks the correctness of the header. So you have the corresponding error code like CRC code as a checksum. So this you can see has given you an idea about the two basic protocols, that is TCP and UDP, being used at the transport layer, and therefore we close over here in this session, and in the next session we shall be sharing some things about the quality of services issues at the transport layer.